Afternoon all. I welcome you all for today's webinar. We at Cambridge Institute of Technology have this regular culture of conducting faculty development programs, and in this crisis of COVID-19, we have shifted over to this webinar series. So today our webinar series is latest technologies in automotive industries. The resource person for the day is Mr. D.A. Karthik. His role is as a key account manager in quality company CG Automotive, Germany. To just give a brief introduction of our speaker, he was our alumni. He was a student during the year 2007-11. As a student, he was a topper for all the years. He has completed his engineering, and he was immediately after that, he was associated with Bosch. Later in 2013, he has moved to CG Automotive. We are very grateful to him when he accepted our invitation readily and was ready to share his knowledge among all of us. To just give a brief introduction to the participants we have here. All our participants range from various colleges across the country, students and some faculty members from various institutes. Over to our head of the department for the welcome address.
Yeah, good afternoon, everyone. We have gathered to witness a webinar on latest technologies in automotive industries. Post-COVID-19 crisis, industries plays an important role as consumers look for contactless gadgets. In this regard, the latest technologies will help in meeting the requirement. Now, I would like to welcome our honorable chairman and a great visionary of Cambridge institutions, Sri D.K. Mohan. I welcome young, energetic CEO of Cambridge institutions, Mr. Nitin Mohan. I welcome ever-encouraging principal of Cambridge Institute of Technology, Dr. Sureshal. I welcome our alumni student and speaker of the day, D.A. Karthik, who has agreed to give a webinar on the latest technologies in industry, automotive industries. And I also welcome participants from various parts of the country and my dear students and fellow colleagues. I welcome for this webinar. Yes, Karthik, you can go ahead with the webinar.
Okay, good afternoon, everyone. So, as there was a brief introduction given, I am an alumni of Cambridge Institute of Technology. I was the student of the first batch. I am proud to be telling that I am the alumni of this college. I have been following the activities done by this college, and I really am honored to be invited for this seminar. Hope the inputs and information what I give will be useful for you and will help you in future in one or the other way. Briefly talking about my career, I passed out as an electrical and electronics engineer in 2011 batch, and then I worked at GE as a quality engineer for 6 months, and then I was an apprenticeship trainee at Robert Bosch India Private Limited for a year, and then since then for 3 years I worked in Robert Bosch Limited as a quality engineer in India, and then currently I am working in Germany as a key account manager quality. So this is my brief background on my profession and career so far. And coming to the topics from today, I would briefly give the introduction to the automotive industry, how the automotive industry works, what is required for the automotive industry, and then I would give some hints on scope of electrical engineers in automotive industry and what are the future developments that are happening due to electrification and where you young students can contribute to the society.
Karthik?
Yeah.
Would you like to turn your video on?
Yes.
Yeah, thank you.
So Currently, I am working with an organization called CG Automotive. This is a global company which has footprints across the world. And as you can see, previously CG Automotive was part of Bosch, and we have the history of over 100 years since the beginning of automotive industry, I would say. So it was known as Robert Bosch Starter Motors and Generators Division, and since January 2018, it uh, is an independent company. And we are responsible for manufacturing starter motors, generators, and then electrification components. So there are a lot of new technologies that are under innovation, but currently I am not allowed to give you some information on this. You can find more information on scgautomotive.com. In India, SCG Automotive is located in Naganathapura. This is Hosur Road, Bangalore. So you can find our location in India, and then there are a lot of career opportunities also coming up with SCG Automotive, and then I hope to cross paths sometime. So coming to automotive industry. So the word automotive comes from Greek, which means autos, which means self. It's like self-running or something. And then Latin means motivus, which means motion, referring to any form of self-powered vehicle. So automotive is a vehicle which moves by itself, or a vehicle which moves with a different energy or no additional power required. So as you can see in the picture, this was the first motor car built in 1885 in Mannheim, Germany, and this was also awarded a patent. Does anyone in the crowd know who invented this particular vehicle? Who owns the patent for developing a first car?
Anybody knows, you can raise your hand so that we can unmute them. Okay, go ahead, Karthik.
Carl Friedrich Benz. In the late 1800s and early 1900s, there were a lot of uh, experiments, innovations, research done by various scientists in Europe, in US, and so on. Carl Friedrich Benz was one of them, along with Mr. Daimler, Mr. Ford, and other renowned scientists. So he was the first guy to design this particular motor vehicle with an internal combustion engine, and he was awarded patent for this concept of the car. And moving forward, how automotive industry was developed. So a car was developed, it was custom made, like if there was a user, some guys used to make it, but a visionary leader called Henry Ford, he said that mass production in the automotive industry would help all the people to transport easily. So it was his idea that the industry was set up, and then the company started to produce cars in mass. So there was a concept laid on, and then they started to build similar cars, and so on and so forth. So Henry Ford has great contribution towards today's manufacturing and automotive industry, I would say. Moving ahead, you can see uh, across the world, on an average, there are about 85 million motor vehicles produced. Sorry. In 2018 alone, in the world, around 98.1 million motor vehicles were produced, and of which 78.7 million vehicles were passenger cars, and 18.5 millions were from commercial vehicle segment. You can see how regions are developing with their growth in vehicles, and India can be seen as South Asian region. So we are constantly around 10%, but we have improved a lot from 2003 to till date. But the biggest scope or biggest improvement is seen in Chinese market. So they have raised from 8% to 29% in span of 15 years. So that's a great change. So we should also see such a development in India as well in future, because we are also capable of doing many more such things. And how do these automotive industries work, and how do they come up with similar products, similar deliveries, so on? So you can see across the world in different countries and different regions, there are automotive governing bodies. So they are like the organization where they bring in the manufacturers, and then they discuss about how to provide something to the people which is safe, reliable, useful, and so on. So on the left, you can see VDA, which is Verband der Automobile Industry, is a governing body in Germany. ACEA is European Automobile Manufacturers Association. AIAG is North American Association. ASEAN is East Asian Automotive Federation. JAMA is Japan. CAA is China. And last one is African Association for Automotive Manufacturers. In India also we have a similar organization. Does anyone know about it? In India, we have a organization called Society of Indian Automobile Manufacturers. So they represent India in various governing meetings, and then they try to put India also in the same standard like the global ones. So here you can see the member groups of Society of Indian Automobile Manufacturers, and most of the companies here are either having bases in different European countries, North American countries, Japanese countries, but we are also proud of many native Indian manufacturing companies like Tata Motors, Mahindra, Bajaj, Greaves, TVS. They are all the native companies who are contributing to the economy of the India, and also giving us very good locomotives. There's one uniqueness what you can observe in India. In most of the parts of the world, you would not see such a graph. In India, the biggest market is for two-wheeler market. In most of the other countries, the biggest market would be for the passenger car vehicles, and smaller part would be for commercial vehicles. But India is a unique market, and that's why we have a bigger share with two-wheelers. And then we have about 13% of passenger vehicles, and then 3% for commercial vehicles and three-wheelers. Commercial vehicles include light trucks, heavy-duty trucks, and then trailers and so on. Also include off-highway tractors, excavators, and stone crushers and other stationary machines as well. Briefly coming on to the structure of automobile industry, how automotive industry works. So everything starts with the concept of supply and demand. You end users give the requirement as what would be helpful for you. Like you would expect a car with so many horsepower, so much mileage expectations, how many seaters, would you like to have a rooftop, or would you like to have an open car? If you would like to have a recliner chairs, if you would like to have hard rock seats, would you like to have navigation system? These are the demands coming from end users. And then comes the OEM and OES. So OEM are called as original equipment manufacturers. These are the companies like Tata Motors, Mahindra, Daimler, Benz, Volkswagen, and so on and so forth. So have they will collect the requirements from the end user, and then they will develop, design, and test the products which can be uh, provided for the consumer for usage. And then comes a market called OES, which is basically spare part market. So whenever there's a car that breaks down, you cannot replace a car, you would like to repair a car. So then you would need some spare parts, but which can be bought in the separate market called OES. And then comes tier one suppliers who would give major components or uh, owned components, I would say, like a starter motor, diesel pump, tires, and seat belts, airbags. These are all coming from tier one suppliers who manufacture them as a component or a product and then supply it to OEMs who will then assemble it on their vehicles. And key suppliers in this line would be Bosch, Continental, Mahle, CG Automotive, and so on. And then comes the tier 2 suppliers who basically make die casting, plastic molds, and so on. And then the supply chain continues until the demand goes to raw materials. So this is how the automobile industry works. And in most of the cases, the governing bodies will be monitoring the OEM, OES, and then the tier 1 suppliers. So there's a lot of focus to deliver safe products, eco-friendly products, and useful products from this OEM belt of companies and then tier 1 suppliers. So that's a brief on how automobile industry works. So like I said, there are n number of companies in the world which manufacture cars, and then there are n number of suppliers, and the chain continues. How do they follow similar standards? How do all the companies do things? And what's the common point? What are the guidelines? How they work about? So I think most of you in the seminar would have heard about a board, International Organization for Standardization, which can also be known as ISO. This is a company that this is an organization which works with different board members of different countries, 164 national standard bodies to be precise. They work towards standardization of processes, procedures, safety related topics, and legal related topics, everything. And this board also has India as its key member, and BIS, Bureau of Indian Standards, represent India in ISO. And the standard what is developed for manufacturing or production is ISO 9001, which has its latest version released in 2015. And this is a guideline which says that all the manufacturing companies of certain scale should have a quality system management. So the management should have different aspects which should be followed, and then it makes the company more robust, and it takes care that the company is following all the rules and guidelines defined by the government for the benefit of the people. Since ISO 9000 was general for all manufacturing industries, IATF, an international automotive task force, was set up focusing on automotive industry. And currently, if any company wants to be an automotive supplier or automotive industry, then they should have certification with IATF 16949, which defines specific guidelines on how to manage your business. On the right, you can see uh, a sample of a certificate which is verified by a third-party service called DQS. And here they say that the company is eligible to deliver products to automotive sector. So coming to quality management system. So what do you feel about quality management system? It says quality, but it talks about the complete business. What do a big company or a business do? Fulfill a customer requirement. How they deliver the products or services required by the end customer. How do they deliver them? They manufacture the products required. Before manufacturing, they should procure the raw materials, they should develop the products, and they should design it the first. So this is how the chain starts. So you design a product, you develop a product, procure the raw materials, manufacture them, deliver them, and then looks for the customer like fulfillment of customer requirement, I would say, or the customer satisfaction. Is this sufficient to run a business? I would say no. There are many other requirements like legal requirements, safety requirements, how to sales and how to do sales and marketing, quality inspections, and what do you do when there is a complaint coming up, and what do you do with the documentation and retention. So there are a lot of aspects coming in. What we should focus here is according to the standard IATF 16949 or ISO 9001, every manufacturing company should have a quality management system. So the company should be able to define what you do in every step. For example, on the legal requirements, you should define who works on the legal topics and how do you monitor the legal requirements that are coming up from an organization. So, and safety requirement. How do you ensure that you will not use some chemicals which are harmful for environment as well as the usage? How do you make sure that there is no child labor in this organization, and so on and so forth? So how do you inspect the products that are developed, whether they are quality check okay or not? What happens if there is a complaint that's coming from? So today you might know that Amazon is one of the biggest online chain. So whenever you have a complaint, you can just say that you would like to return the product, and then they will pick it up. So this is the easiest way. You will get a replacement. But that's not the normal way of working, and you should always see how these complaints are generating, and you should work on how to analyze these. Sales and marketing, how do you market them? You might have seen a lot of television ads, so they are all coming from marketing team. And sales organize, sales work on which part of the market they should focus on, how much delivery should they do, should they focus on rural sector, urban sector, should they reach to individual houses. So this is all done by sales and marketing. And documentation and retention, so whatever processes and guidelines you follow, drawings you develop, they should all have a tracking, and then you should maintain them according to the legal requirements. Some documents are to be held even for 35 years. So that's the strict guidelines what automotive industry follows. And this is a brief introduction of quality management system to you guys. Moving ahead, I would shortly give some hints on my profile. Currently, I am working as a key account manager quality, and my biggest role is complaint management. So if I have to say in layman's word, I would be a doctor who will be doing a post-mortem. So I would get all the complaints from different customers. I would analyze these complaints. I would try to find out what happened with this complaint, why this complaint occurred, how we can eliminate this complaint, and so on and so forth. So various uh, industry experts, reformers, they analyzed how these complaints or non-conformities are to be are relevant to money. So in a business, it's normally money. So a person tries to develop some products, manufactures them, and sells not for fun, but for money. So they would like to make profit. And if at all a defect occurs in this process, you would like to, it would be pretty much um, relevant in some part of the supply chain. So you can see how the defect costs are relevant. So if you find some fault during the design of a product, then if it costs one fold, during implementation time, if you find a defect, it's 6.5, testing it's 15, and once the product is delivered and returns, the cost is 100. So if you make a design which is foolproof, then you would save a lot of cost. So that is where I am working on. Whenever there's a complaint coming up after delivery, we work with the design team and make sure that this problem does not occur with the future products. The basic standard used in automotive industry to fix the complaints are 8D methods. So 8 disciplines problem solving method. This was developed by Ford Motor Company. Like I told in the beginning, Ford was one of the visionary who brought in mass production for automobiles in early 1900s. So this was the company which also established this methodology where they use 8 steps to solve a complaint. So in D1, you define a team who will be working on what. Most probably it would be a cross-functional team where people from design department, people from quality department, people from manufacturing department come together. They analyze the part and describe what the problem is. Like I said, I would be an engineer who would be doing postmortems. So if I have to say, I would say a particular component has failed because the winding was not wound properly. When I take a case of a stator or a rotor, so I would say if there's a failure in a stator or rotor, I would say the winding was not wound properly, there was an internal short, and then I would describe my problem. And then comes implementation of containment action. So what they do is there will be a short-term actions which will be taken to make sure that further defects will not be supplied to the customer. And then we define the root cause, why the stator was not wound properly, whether it was a manufacturing fault or whether the uh, wires were not according to the specification and it broke when you are trying to wind it, and so on. And then develop permanent corrective actions and then implement this corrective action and then make sure that you will not do such a mistake in future. That's called preventive recurrence. And in the end, you acknowledge the work from your team and close this. So this is a brief introduction of 8 disciplines problem solving method, and this is my bread and butter, I would say. So a brief hint on how these complaints can affect various customers. Here you can see the consolidated amount paid as warranty. Warranty is the money paid by the companies uh, due to the failures delivered to customer. So you can see year on year how much money is spent. So about 45,000 million US dollars are being spent on warranty by various automotive companies across the world. If you remember the big Dieselgate saga in 2017, where Volkswagen in North America released a particular product which was not according to the environmental standards, then the company had to pay a huge money and they had to recall uh, so many cars because of this topic. And then in North America, the cases are still going on where Bosch is held responsible for such a defect because Bosch was responsible to develop and deliver a particular diesel pump, and they had to fulfill certain legal regulations with respect to the emissions of this particular vehicle, but they faked the report. So they said the product would deliver even though the product failed to deliver. and then they certified this and then released it to the market. And later, when it was analyzed or identified by the governing body, there was a legal case against this, and then the proceedings are going on. Similarly, General Motors recalled for ignition switch problems. Toyota had some acceleration problems. We don't really hear such recalls or problems in India because the automotive sectors in India, they prefer replacement fitting. So how it works is you will not even get to know whenever you have a problem with your car, when you try to get it repaired or when you go for the first service or the second service, the your dealer, he would check the car. If your car is identified in the risk zone, they would replace the faulty component and they will not even let you know because this cost is bared by the company. They would give the specific instructions to the dealers that they should repair this particular thing, and then your car works fine for 10-12 years and you will not be knowing that there was a defect and it was rectified in your car. And this is a report for Indian and Korean companies. Here the report is only from Tata because this source for this data is warranty week, and then they only got data from Tata. Other OEMs, they did not support it, and thus you don't see the data from them. You can see Tata being an Indian company uh, which works with rupees has paid about $1.24 billion uh, as a warranty cost. That's really, really huge amount what we are talking. So it signifies that defect-free manufacturing or designing is one of the key aspects in manufacturing industries. So that was a brief about my profile, introduction to automotive industries. If you have questions in the end, maybe you can ask something and maybe I can explain some things. Moving ahead, I would like to discuss the scope of electrical engineers in automotive industry. In the beginning, we saw in 1885, Mr. Carl Benz invented, uh, designed a motor car which worked with internal combustion engine, and then he got a patent for it. But before that, in 1881, French inventor Gustave Trouve demonstrated a first three-wheeled car powered by electricity. So an electric car was developed even before the internal combustion engine. So we could be proud that to be electrical engineers and say that electrification was way before. But these concepts were not successful because of the resource issues, and even today we are working on these particular problems. So how can electrical or electronics engineers contribute in automobiles? A car does not have mechanical components alone. The car also has a lot of electrical or electronic components. For example, battery, which is required to run most of the electronic components. There's the engine control unit, which controls what an engine should do, how a car should perform, and what it's like a CPU of a car. And then comes the navigation system and the infotainment system. This helps you to have your route, speak on phone, navigate you to the right directions, listen some music, change the heating, change the cooling temperatures, etc., etc. And then comes the starter motor, where you would be easily starting the engine with one button press or switching your key. So that's a contribution. And then comes the alternator, which keeps this battery running and charged all the time. And then comes the wiper motor, which is used to clean your windshields. So there is a lot of electrical or electronic components where electrical engineers can contribute in the automobile industry. Apart from this, there's a big change that's anticipated in the automobile industry because of reduced fossil fuels available, and then also the climate changes what we are seeing, how the climate is getting drastically affected, global warming, increase in CO2, and these are the factors that drive us to towards electrification, I would say. So just to begin with the electrification, the global passenger car market at glance, let's see what happens here. Electrical automobiles came into picture very recently, and in 2018 the sales of this particular cars rose by 74%. But when we see the scale with respect to the internal combustion engines which use fossil fuels, this is less than 0.5%. So overall, there were about 1.2 million electric cars which were manufactured and sold. But compared to the 98 million motor vehicles manufactured, this is very, very less. And also, there's a new trend where people are inclined towards the big sport utility vehicles like XUV or Ford, Ranger, Toyota, uh, what's that? The big car, Altis, or so on. And then this is also a factor where it affects electrification. Uh, there's a big scope for growth of electrical vehicles in the market, but it needs a lot of time. We will see the details in the next slide. And then on the right, you can see how good electrical vehicles can be for the climate. So diesel emissions are considered as the benchmark on this particular graph. If you use a gasoline engine, you would be emitting about 10% more carbon dioxide into the environment. So this is more dangerous than the diesel. And when you use a plug-in hybrid, you would save a lot over the lifetime, about 20% or 30% over the lifetime. If you use a complete electric vehicles, you would reduce the emission of carbon dioxide over lifetime by about 65%, but during the operation, it will reduce about 90%. So using an electrical vehicle, this much of good you would be doing to the environment compared to the use of an internal combustion engine. This also has a counter advantages. When you see electrical vehicles or plug-in hybrid vehicles, it is having a very high cost. It can be due to the cost of the battery or the technology itself. So a full electric vehicle would cost you 30% more than a normal diesel car. So this is the aspect where the industries are working today and trying to see how they can reduce these costs and bring electrical vehicles into market similar to the internal combustion engines. So what is the driver that makes us go towards electrification? As you all know, there are this global warming that's happening, the environment, the glaciers melting, the water level rising, the air is not pure enough, and you have the symbol, you have the proof here. In 2015, we had about 400 grams of carbon dioxide released, but when you see it today in 2019, it's already 410. So it's increasing every day. So we should also respect the environment we live in, and then that is the biggest driver that's coming up with us to use electric vehicles or renewable energy resources in today's world so that we can make our earth more greener. in the coming days. You can see here of the total carbon dioxide emissions across the world, 14% is coming from the transport sector, and 95% of which are caused by combustion of fossil fuels such as diesel and gasoline engines. So in Europe, passenger cars account for 12% and commercial vehicles for 5% of the total CO2 emissions. So this is a brief hint of how automobiles are contributing for CO2. Other things are like for development of electricity, the biggest is coal energy, which is burnt to generate electricity, is generating very high carbon dioxide, and other mining uh, operations or mining industries are also contributing for the emission of CO2. So there's a lot of scope for improvement to make our environment friendly. So here you can see overview of carbon footprints, how different countries are working with respect to the reduction of carbon dioxide emissions. So here you can see where India stands. We currently in 2020, India emits about 120 grams every kilometer a car is moved, and which is very high. And the target for India in 2025 is to reduce it to 113, which is less, but still an improvement, I would say, when we compare it with Europe, China, or US, where they are way lesser. And then there were different targets given to various OEMs. By end of 2021, to reach 95 gram of CO2 emissions per kilometer. And this is a status whether they can reach or not. So as of today, Volvo is on target. The cars produced by Volvo release carbon dioxide less than 95 grams. And they are in green. Toyota is green, Honda is green, and then Jaguar Land Rover, also an Indian owned company, is green. And you can see most of the other European customers are red, and they emit more than 95 grams, and they are currently working on various products that would help them come on to the other side of the screen. So current status of the passenger car market, how it's developed. So here you can see how the market of electrical vehicles are developing in different regions and different types of engines. So PHEV is plug-in hybrid vehicles, and BEV is fully electrical operated vehicles, battery electric vehicles. And then this you can see region wise how the graph is going on. So the increase of these vehicles is seen regularly, but we do not see this completely change in 1 or 2 years and see all the auto vehicles coming into the market tomorrow. So it needs time, it needs a transition time, and this is not expected as in until 2030 or 2040. So this needs a lot of time. So here below you can see the roadmap across the world. What are the different markets we have currently? So 12-volt internal combustion engine is occupying 50% of the market share today. 12-volt internal combustion engine with start-stop system. So this is a technology where CO2 emissions are reduced by switching off your engine when not in use. Example, when you stand in a traffic signal and then you are not using your engine, then automatically the car shuts off. And when you press the accelerator, then it switches on it by itself. So this is a technology which saves a lot of carbon dioxide. And then plug-in hybrids and fully electric vehicles are about 2 to 3%. This graph changes significantly but we can still see about 20% of internal combustion engines running in 2025. So this is how the market progression is being done. And what are the key drivers for electrification? So social awareness is one of the biggest driver. So as a person using the car, you would not like to be called like a environment destroyer or something, because of your usage of car, you are polluting the environment and then making it difficult for other people to survive on. So that's one of the biggest uh, driver. And Dieselgate is one of the lesson where most of the people around the world learned what happens with the CO2 emissions. And seeing this, many politicians in the country also in many countries are pushing for eco-friendlier mobility. Even in India, you might have seen a lot of push given towards electrical vehicles and electrification, even though we know that we do not have enough resources to completely change into electrification. And one of such steps taken recently was increasing the Bharat standard. You would know there until 2 years back or 1.5 year back, we were working with BS4 standards, which defines the emission norms in the country, but the country implemented BS6. We skipped BF5 because it was not practical anymore to have a BS5 and then BS6. Currently, Europe is working with Euro 6 standard. Similarly, India is working with Bharat Standard 6. And this is also coming with stricter CO2 regulations, and then to meet the CO2 targets, and then individual consumers where there are certain bans put on so that they could keep the places clean. So these are the key drivers for electrification. And coming to the obstacles for electrification, what are the big obstacles? What we see currently is resources, and we do not have enough electrical electrical energy developing possibilities which are clean. So that is also a big problem. For example, in Norway and France, they use different energies to generate electricity. Norway uses hydropower. 95% of the power generated in Norway is hydropower. And then France uses 100% nuclear energy for power development. And then these countries can have very good uh, benefits with the electrification of vehicles. Whereas in India, 60% of the power is generated using coal. And this again develops carbon dioxide, and the benefits will not be so easy in India. So electrical vehicle is not automatically beneficial for the environment. For each kilowatt of the battery power, around 100 to 150 gram of CO2 are emitted in production. So when you want to generate this kilowatt of battery power, then you are already burning or emitting 100 to 150 kg of CO2. Thus, the electric vehicle starts with a mortgage of several tons of CO2, which is then paid off in grams per kilometer. So first you pollute the environment and then you try to clean it. So this is the current status of electrification, which needs to be changed. And then another obstacle what we can see is the raw materials. So the battery technologies need, currently we can see lead acid batteries, lithium ion batteries, and also cobalt batteries, which are proven to be very effective in battery technologies. But all this cobalt is manufactured or mined in hotbed of Congo. So it's also difficult to procure these particular raw materials and also see how these can be recycled. It should not become another plastic where we cannot get rid of it. So the battery technologies what we develop should also work on how we can recycle them. So this is also a big challenge. and then infrastructure for charging. There are in 2018 across the world there were about 5.5 lakh public charging stations, and which are expected to go out to about 14 million by 2030. So public charging stations are very much required because it's not a viable solution for everyone to have a garage and then charge their cars in the garage. So public charging stations would be a big solution, and then India is also working to develop such charging stations, and Europe already has some. So this is also a challenge to develop the resources for charging. So here you can see the market perspective of India. So passenger car sales in 2018 was about 3.9 million, which is forecasted to be 8 million in 2025. And currently, electrical vehicle sales are about 3,300 pieces in the complete country, which is expected to reach 270,000 or 271,000 by 2025. And here you can see the powertrain mix. So 93% is internal combustion engine, and then 7% is internal combustion engine, which is start-stop. And by 2025, this is expected to have some plug-in hybrids, 48-volt technologies, and battery electric vehicles. So the graph may change, but not too significantly. And here you can see the energy mix with respect to what kind of energy we use. We have about 80% consumption of fossil fuels, 17% renewable energy, and 3% nuclear energy. And by 2040, this is expected to change a little, where our dependency towards fossil fuel will reduce to 56% and increase our renewable energy resources by 38%. So currently public charging stations, what we have for the entire country is 352, and CO2 target is 113 grams per kilometer. And market saturation is expected with 22 cars for every 1,000 people. And on the right, you can see the electrical generation in India, what kind of energy resources we use for power generation. You can see our biggest contributor for power generation is coal. We are very much behind in use of renewable energy resources, which is expected to see huge development, and of course contribution from all you electrical engineers. And then natural gas and the nuclear power is also seen to grow. So currently, what is the status of electrification in automotive industry? There is a big challenge in automotive industry today, which says electrification is possible, but also is very challenging. One, because of the energy what we have. Two, we have the resource constraints, and then three, the reliable technology itself. So there are multiple technologies that are coming, but we still do not have a solution like internal combustion engine, which dominated for entire century. We are still looking for a best solution. And according to the current forecast, 85% of the passenger cars manufactured in 2025 will still be internal combustion engines because of this same resource constraints. Maybe we have some established technologies with high voltage cars or hybrid technology. Meanwhile, other approaches such as alternative fuels or natural gas or the fuel cells could also be a solution. But overall, in a summary, if I have to say, there is no right technology, and it creates a lot of opportunity for the new engineers to come into the market and give their innovative ideas, which could save our environment as well as give good mobility to the people. Also, if we are working only on the future, like what will be the new cars developed, what will be the new energies required to drive a new car, what happens to the existing cars. You know, we already saw that about 100 million cars are sold every year. What happens to these internal combustion engines? So there's also scope to develop alternate fuels like biofuels or synthetic fuels, which do not produce carbon dioxide. And then this is a scope of area where we can work as well. So this was a short brief or summary from my side on current status of electrification. The technologies are being developed. There are various scenarios, various products available in the market, but most of them are under development, and I am forbidden to speak about it today. So maybe in a year or so, when there's a next seminar that's conducted, when the product is free to deliver outside, then I can give more information on such projects or products. So any questions?
Yeah, participants, if you have any question, you can put it in the chat box. Any questions?
If there are no questions,
No
then
questions? Yeah. Oh, fine.
then I would like to end the session. Thank you for your patience listening.
Chat box ಅಲ್ಲಿ ಹೇಳಿತ್ತು.
Thank you, Karthik.
Yeah.
First of all, I thank you for your ready acceptance of our invitation and the time you have spent with us. I also thank you for your extensive information that you have provided for about the automotive industry functioning, organization of the industry, the structure of the entire industry, and at least I was not aware that complaint management itself would be an important wing in the industry. With the roles of electrical engineers in automotive industry, the electrification process that is there, and how we can contribute towards the cleaner, greener earth of shifting ourselves towards the electric vehicles. I thank you immensely for your presentation. I also thank our management and principal for their continuous encouragement and facilities, our head of the department for his support, and all my fellow colleagues for their active involvement in the webinar. Last but not the least, I also thank all the participants from various organizations across the country for their participation in the webinar.